We're going to be talking about design thinking for artificial intelligence and machine learning today. The objectives for this tutorial, I'm going to start with what, at least the way I see it, what artificial intelligence is not. I'm going to talk about a brief introduction to design thinking and the methodology. I'll present a really short case study that we did at Philosophie, and then kind of pepper that through the entire presentation. I will give you a tour of really kind of techniques and workshops that I use to get at the nuance of artificial intelligence. And then really what I want you to walk away from this talk or this tutorial with is really an understanding of how you could use design thinking as a framework to build really human-centric AI products. So I'm Chris Butler. I'm Director of Artificial Intelligence at Philosophie out of New York. We're a design consultancy, and so we work with both very large companies that need help doing innovation, but also we work with very small companies that need help just getting their idea to live and breathe. We also have offices in Los Angeles and New York. I have about 18 years of product and business development experience. My original degree was in computer systems engineering, focused an awful lot on actually network theory as a TA while I was there. Worked for a bunch of different companies, Microsoft, Waze, Horizon Ventures, which is a lesser known VC, but you've heard of almost all the companies that they've invested in, one of which is DeepMind. And Kayak. I've also started my own company, and I'll tell you about why, maybe one of the reasons why it failed as we go through this story. And this is my email address, and then my Twitter handle in case you want to say nice things about me on the internet. So let's start with what is AI, and we'll try to do that in 5 minutes. Because you're here to learn about that probably. How many people, actually just to get a show of hands, how many people are actually, say, data scientists or, okay. What about like researchers, academics? Okay. What about engineers, just regular engineers? Sorry, you're not regular, but, and then product people, all right, designers, cool. Executives or other stakeholders, okay, cool. So there's a lot of people, great. And I'm always gonna start with what it is not. I'll talk a lot about what it is throughout this entire talk, but I think part of my job a lot when working with clients is trying to pull them back from what they believe things like data science, machine learning, and artificial intelligence is, and then try to rebuild that up to what it actually is capable to do today, and then maybe what to expect from it. So the first thing is it's not just about chatbots. So everybody is going to be asked to actually write a chatbot. They'll probably fail at it. And then they'll move on with their lives. But it's not just about chatbots, right? There's a lot of other ways that things like prediction capabilities, automated decision-making actually comes into products. It's not magic fairy dust. You can't just sprinkle it on a product and suddenly everything will be better. It's also not, I mean, I'm not a singularian. I don't believe that necessarily there is as big of a problem as we think when it comes to existential threats. I think there's a lot of other ones that I'm more worried about. And it's also not something that really mimics human beings and probably not something that we can fall in love with. I mean, people feel a lot of affinity for the Roombas maybe, but it's not something that we really can emotionally interact with in any real way at this point. And I think the expectations are also bundled up in the way that we sell a lot of this stuff. So if you type in AI into Google image search, this is what you see. And so there's all these like blue glowing brains. There's lots of personified plastic white robots with human faces looking at human skulls apparently. And this is not what AI is either, right? Like it's probably much less about this idea of a singular entity, and it's more like an ecosystem. And I'll talk about this a little bit later, but I think this is maybe one misconception, is that it's always this one thing that you're going to ship, and you're gonna buy like 3 AIs, and then you're going to install them in your company, and then everything will be great. That's not the way it is. And also, when we talk about automation, automation is not just something that we do using advanced technology. So this is an example of a self-checkout where they've offloaded the responsibility of checking out to someone else, and this is not using special technology, right? This is a touch screen, a credit card reader, and then maybe some voice commands, but there's nothing special about this. This is something that has been built probably 10 years ago. So automation itself is not something that is even necessarily mimicking human intelligence. So what is it? right? And I found this definition set to be the most helpful, and it's from David Robinson, who's the chief data scientist at DataCamp, which is again, I don't work for them, I don't get paid by them, but if you want to get an introduction to coding aspects of it, it's pretty good. But data science is really about producing insights about something. Machine learning is about producing some type of prediction, and classifications are predictions too. And then artificial intelligence is really about producing actions of some type. So I found this to be helpful. So let's use this as the working definition as we move forward. And the truth is that when you are building things that maybe utilize artificial intelligence, you have to have the other two components before you can do that. And so you need to be able to make predictions about the world, about the way the world will be, what would be the best thing to do. You need to be able to recommend things. And then from there, you make decisions. And same thing with data science. You need to be able to understand insight about the world itself to be able to take action on it. So I'm going to switch gears really quickly. That's all I'm going to talk about when it comes to AI as far as an intro before we start talking about the melding of design thinking and AI. But probably, how many people are familiar with design thinking or have heard of the term before? Okay. How many people actually practice what you would call design thinking? Okay. So design thinking, what it boils down to is Sharpies and Post-it notes. I'm just kidding. There's definitely, I'm sure that there's some type of secret, cabal of Post-it notes and Sharpie manufacturers that are promoting education of design thinking, but it's not just about that. I was looking at a bunch of images of kind of like big companies that do AI or machine learning today that do utilize design thinking. Like IBM is one that has really embraced that. And the pictures are always of like a glass wall for a conference room somewhere with a bunch of Post-it notes and people kind of like standing there like, this is really interesting. But that's not what design thinking is, right? And maybe to talk about what design thinking is not, this is Natasha Jen did a talk about design thinking being bullshit. And I think this is related to the fact that once anything as a framework starts to become more popular, it starts to become more theater for some organizations, right? And so cargo cults, whatever you want to call it, this idea that the reality of allowing everybody to get access to design thinking means that a lot of people will be doing kind of the ceremonies but not really getting the main point of it. But it could also be that once you start selling kind of certifications in design thinking, which is what Agile went through, right, you start to lose the real essence of what it's meant to be. And there was a response by Kovin who talks about like, yes, design thinking is bullshit, but it's still good. And the reason why is that he references the cathedral and the bazaar, right? And so when we talk about design in general, I think, no offense to the designers in the room, you guys can get a little uppity about the way that you consider design, right? Design isn't everything, right? And that's something that is the title of a butchered title of a famous book by a designer or researcher. But the cathedral and the bazaar is really about, should only a few people be able to practice something actively, as in the cathedral, or should it be more about a marketplace of ideas? And I guess coming from my standpoint, partially because I've been a consultant for the last couple years, but also because I've just found that, as a recovering product manager, learning about all these different frameworks, processes, techniques, this is something that we learn from over and over again to be able to apply to situations. And so to me, design thinking is really, it's benefited by the idea of that it's not only just these things that we're going to talk about, what is design thinking, but it's about like all these other concepts that we start to pull in. And so I can just say that like whenever I do a kickoff for a particular project, whether it's my own or someone else's, it's always a mix-up of things that I think matter for what the outcome is that we need. And that's what I would say is design thinking is really meant to be about a particular outcome that we'll talk about. And that outcome is really about human-centered design. So the idea is that, in a lot of older automation kind of academia would talk a lot about this idea of the operator is the main person that's interacting with automation. And then there's the designer. And the thing that is pretty important is that when the designer doesn't take into account the operator, you cause a lot of problems. And so design thinking is at its core about pulling in the people that would be the operators of the automation to actually be part of the design process in some way. And that's really important. This is the D School from Stanford's version of the design thinking process. And so each one of these steps is really about how do we understand the person better and make the person a center point of this actual process. So empathize, and these are the 5 steps. These are generally what most people, IDEO I think uses something very similar to this. There's a bunch of other people. IBM has, I think, an infinity symbol that they use for theirs. But again, the core of human-centered, I'm going to reference D-Schools just because I think it's probably the more well-known. And there's a lot of great resources online for free if you want to go look at D-School's website. It will be in the link as well. If you want to do like a full design thinking sprint, like kind of a mini one in about an hour and a half, they have a video of that, which is really great. But you're going to get to actually go through this for something that's going to be focused on artificial intelligence. So empathize is really about how do we understand more about a particular situation of a person. And that's usually a person that you're trying to solve a problem for. I think empathize is maybe a little bit of an overused term today. I'd almost go with that you want to be more compassionate towards people. But in the end, it's about trying to understand someone else's context. The next thing is define. And define is really where we're going to zoom in and we're going to try to understand what are the problems that we really want to solve for the person, and then what about those problems are really important. And again, you'll usually do, once you're empathizing, you're kind of understanding a person's context. Define, you're going to be talking with them to understand what problems are important to them, what particulars of that problem are important to them. And then once you have a good definition, you move into the ideate phase. And the ideate is really about how do we now, based on the problems that they have, we start to come up with solutions that could be beneficial. And then at the point of the prototype, that's when you actually build something. And prototyping is not meant to be something that is very complicated. It's not even meant necessarily to be something that is fully built, but it's something that you use as a symbol. And I'll repeat that later when we go through the prototyping phase of this tutorial. But it's really meant to be more of a symbol where the person themselves that's going to be utilizing this service or application that you're building can actually interact with it in some way and can see that you've took a stance on something. And then from there, they are allowed to give feedback. And that's part of the testing phase, is that you're actually going to go off and have people try this out. So those are the 5 phases of design thinking. But the question maybe becomes like, what does it mean to do this when it comes to human-centered AI? And I like to go back to this definition where, in the end, it's about insights about people, right? It's about predictions for people to use or about people. And it's about actions to actually help people. So in the end, even though AI, machine learning, all these things are very complicated tools, very complicated technologies, we're reorienting it to say that this is all to the benefit of a human being somewhere. And so, I get this question sometimes, usually from engineers, right after this presentation, which is, what does design thinking have to do with AI? And I like to use this phrase, which is that we shape our tools and thereafter our tools shape us. And what this really means, and so this was John Culkin that is credited, but it could be Winston Churchill who said it about buildings. And so what this really means, though, is that technologies that we build are really mirrors of us. And sometimes it's the black mirror, right? If we're talking about that idea of dystopian kind of view. But in the end, everything we build is in response to something that we need. And there's no such thing as a tool that exists without some type of human impact. If it does, then it might as well not exist. So that's what I'm throwing out there. So the first case study I'm going to talk about is something called field service operations. And so field service operations, if you're not familiar with it, is essentially when you can't take an object and return it to someone to be fixed. So in the case of, say, the air conditioning within this building, probably can't be removed and then taken somewhere and then fixed. So what they'll do is they'll take field techs and they'll send them on site. And they'll try to fix whatever the problem is. And so this could be very large things. It could be very small things. In this particular case, we were working with a company through Google and PricewaterhouseCoopers on behalf of a field service operation company that focused on gas stations. And so what was really interesting about this is that it's not just the field tech that matters, though. There's also dispatchers that are helping organize their work. There's a warehouse of parts or a part ordering system. There's managers and executives. There's customer support. There's the clients. There's lots and lots of these different people that are actually involved in this. And so for this particular project, and I'm going to go much deeper into a lot of these things, but I ended up spending about 3 days on one of these electricians' trucks, just seeing how they do their job. And from there, we ended up building a lot of different things. So we actually built a chatbot named Patrick, who did a horrible job at actually helping the field techs. We then, from there, started to see different leverage points. We built a field tech job management app. and really focused a lot on that dispatcher workflow service. And so these are some examples of both actual coded prototypes and fake prototypes that we ended up building. So I'm going to be using this as an example, right? Because a lot of what we did here actually involves various prediction capabilities. So there was scheduling, which is kind of more constraint optimization, along with prediction or recommendation services. There was the concept of how do we start to understand whether a job is ready to be dispatched, what information would be needed, what parts could be automatically ordered. All these things are prediction or in some way kind of artificial intelligence systems that we could build. But there's not just one, right? Like there were many, many different things that we were testing here. And a lot of them, which I think is maybe a testament to this process, is that we didn't even build them. We just tried to understand whether they'd be helpful, and then we started to understand what it would mean to build them. So I think that's really powerful. And in the end, we ended up helping dispatchers understand the way that their work actually happens when it comes to dispatching out field techs, and ended up being moved forward with a couple other clients. And so anyways, it's a very interesting project. I think it's a good point to talk about throughout these different phases, and I'll try to reference those as we get to them. So going back to this 5 steps, right? We're going to start with empathize. And empathize, we really have to ask the question about who are we empathizing with. And so it really is people in general, because we're going after human-centered design. And there's a subtle weirdness that starts to happen here once we actually have systems that are intelligent or non-deterministic in some way. And so I'm not saying that we necessarily empathize with the machines, but we have to understand how these machines, because they're complex in some way or not easily understood, how do we start to look at them within organizations? And so this is from Chen-Hao Tan talking about what's called the human in the loop, which is something that comes from kind of automation, academia, and the military. And so the idea is that the automation in some way is basically providing some type of result. It could be a decision, it could be a prediction. But then the human being is actually providing feedback or additional information, and then the final result or action is actually taken by the machine. And so this is a very standard way that people think about things when we talk about human HITL, human in the loop type of discussions. This is what generally people consider. There's also the opposite, which Chen-Hao talks a little bit about, which is that the human is actually querying the machine in some way actively. And again, it gets a little fuzzy about which way is which, but in the end, who is actually provoking the discussion or the interaction is really what this means. And then next, Brad from Stitch Fix, who's the VP of data science there, did a really great talk about humans in the loop in general. But once you start to understand that a process is more complicated than this, in their case, if you're not familiar with Stitch Fix, it's basically it ships you a box of clothing, usually 5 articles. You decide whether you want to keep them or not, and then you send them back, right? And so they use both humans and machines to try to make predictions of what types of things I would be interested in. And I'm actually a user of Stitch Fix. I'm only wearing pants from them right now. But you may find me sometimes with a full outfit from Stitch Fix. But what it comes down to is that on the far right here, there's the customer getting the box. But before that, there's actually an interaction between a stylist, who's a human being, and then a machine learning model which tries to understand not only the person themselves, but also trends in the market, and then what is available on stock. And so there's a human and a machine that are interacting at this point from the standpoint of the stylist. But you could imagine now there's many, many, many different loops that are happening out there. And so there's a loop with the warehouse. There's a loop with a manufacturer or white label producer of clothing. And so all these things start to interact with each other, and it actually gets more complicated to being more like a graph, right? And so in this case, Evelina did this graph of interactions between different Star Wars characters. And the reason why I wanted to show this is that it's both humans and machines that are really in here, even though it's fictional. But it ends up being more like a graph of interactions or more like an ecosystem than it actually is about one human being interacting directly with some type of app or web service. And so that's something you should think about when you're considering this. And then finally, this is a scene from War Games, which, spoiler alert, if you guys have not seen it yet, this is Whopper, which is a true human out of the loop system that takes over all of the capabilities for nuclear war. And in the end, almost blows everybody up, then plays tic-tac-toe against itself and learns something special about humanity or problem solving or decision making. And it doesn't. But the truth is that I use this slide as an example of when people talk about human out-of-the-loop decision-making, there is no such thing. Even when we talk about the idea of autonomous weapons, there's still someone that the weapon is being pointed at, right? There's always someone that is a human that is in the loop. And so what I think this really is this gets down to the idea that when we're drawing these system boundaries about what are we affecting, we're drawing them too narrowly. Right? And so it's not even just about the operator necessarily and the designer and the team, but it's about everybody else that's actually impacted by that. And this is really, really troublesome. There's a great article in The Verge about people that were having their benefits adjusted based on a new system. And the truth is that they had never considered how those people would actually escalate or disagree with what they were getting. And so they were basically removing the most important person out of this entire process, and that's bad. What that means is when I think about how we actually start to understand these people that we're talking about, how do we actually empathize with them, there's a couple techniques. And so the first one is what's called contextual inquiry. And contextual inquiry is essentially a technique of just sitting there and shutting up and letting them do their job. In our case, again, the example of me sitting in an electrician's truck for a couple days, watching them do their job, watching them how they interact with dispatchers and other field techs was a key component of that. We also did that with dispatchers. We sat in the dispatcher room and just watched them do their work. Contextual inquiry is really important because you're seeing how people start to cobble together solutions. You'd be surprised, for a lot of industries, probably your biggest competitor is usually a spreadsheet, right, or a whiteboard, or email. Right? Those are all your biggest competitors, essentially, when you're building a product. And so you learn about that. You learn about how people actually do this. And in our case, when it came to field service operations, for this particular client, is that they not only had something like a calendar, they had a vehicle tracking system from Verizon, they had an actual paper book calendar they referred to as the Bible, which included everybody's time off dates and important jobs, as well as email, phone calls. There were phone lists on the desk. Understanding how their environment works is really, really important when it comes to design thinking. The next thing is problem interviews. And so problem interviews, and maybe like just one thing to note about this, when we talk about it from the standpoint of AI, right, this is actually probably the least technical aspect of everything you do in this case. Because what you're trying to understand is you're not trying to actually figure out at this point, like, what could I build that would be a better prediction system for them? What you're trying to understand is how do they actually interact with their world? And that's very key because those interactions that you're starting to collect and understand really get you to the point of understanding where you can start to intervene or where you can build systems that will interact with them. Problem interviews. So problem interviews are essentially where you do some type of interview where you're actively asking questions. In the case of contextual inquiry, you're more watching and asking for clarification. Problem interviews are you get someone either on the phone or in the room or you're on site with them for somewhere in the range of 30 to 45 minutes. And you're actually asking them a bunch of things. But what's special about problem interviews when we talk about artificial intelligence and machine learning, it's more about understanding how they do, it's not only understanding how they do their job, that's a key aspect of problem identification, but you want to start to understand how they deal with things like errors. Because the truth is when you're building something that's non-deterministic, you don't know how it will operate all the time. And so understanding what is the actual organizational issues that come up when errors happen is really key. Because you need to build something for that. In the case of how would you explain your understanding to someone else, right? This is a really interesting question to be able to understand what data or what canonical stories do people tell to other people that help them build mental models about the way that their world works. And I'm going to talk a lot more about mental models later, about how to get into them a bit more, but I think that's something that's really key when we talk about artificial intelligence is not only if you're building some type of machine learning system to take over a prediction aspect, you need to understand their mental model because you need to understand the context, you need to understand the different data points they utilize that are either stored somewhere or not. But you also need to be able to understand how do they now transfer that information to other people. And then trust is the last part that I think is very interesting. And I'm going to go into this a lot more kind of in the prototyping phase, the testing phase. But trust is one of these key aspects that really you can't get past when you talk about automation integration with human beings. People need to in some way understand they need to be able to trust what they're working with, and if they don't, they replace it with something else or they ignore it. But trust can go both ways, right? Like trust can both be good and bad. So you can overtrust something. We'll go into that more. But I think starting to understand how people think about these different things is really key during the problem interview, and it's maybe a slight nuance than just asking like, how do they do this problem today, basically. The next thing is rich picture. And so rich picture comes from soft systems methodology, which is like from the 60s and 70s. It was post-cybernetics where people were trying to be very systems oriented, but then realized that there were like these other squishy things within systems they couldn't really figure out, which were human beings. And so they came, this is one aspect of the methodology of soft systems, which again, I'd recommend. It's very hard to find actually digital copies of these books, but you can buy the book still. But one of these techniques is called rich picture. And so rich picture is with your actual customers, so the people that will be impacted by whatever you're building, you start to build this graph of understanding of how they interact with people. And so this is the actual rich picture from the field service operations project. And so in this case, there's the field tech, there's different dispatchers, there's executives, there's clients, and it's not just about the people and the way they interact, which is very important. And so you can see up there's like kind of things that look like guns or swords crossed with each other. That's where we're trying to gather where there are conflicts between people or where there's friction. But it's also other things, like what are other systems that they integrate with on a regular basis today? Where are the databases? In this case, there was a CTO and kind of a engineering developer person who basically had pieced together this solution of a couple different MySQL databases, an Access database, a couple different workflow tools, and a few other things that were all behind whatever the dispatchers and the field techs were doing. They even created their own Android app, which was very interesting. But anyway, so understanding all these different pieces and how they interact with each other is really key. So it's almost like part system diagram and part human interaction diagram. But rich picture I find to be really, really helpful to understand that. So now, what we're going to do is I'm going to have everybody try to empathize with each other for one moment. So, and I'm going to be asking you to actually do things during this tutorial, unfortunately, as much as all of you would like to hear me just talk for 3 hours. So what I'd like you to do is I'd like you to pair up, okay? And I want you, when you pair up, we're going to basically choose who's going to talk first. One person will talk for 1 minute. Then you're going to switch. The other person will talk for another minute. And what I'm going to ask you to do is I want you to talk about the last time that you were in a car. And it could be an interesting story, but it could just be like the last time. And so anyways, why don't you guys take some time to pair up right now, and we'll do this.